Well, good afternoon. If you're in Asia, thank you for joining us. My name is Ali Hassan Begi. I am the founder and CEO of Global Efficiency Intelligence. We are a consulting firm based in the US, doing work on industrial decarbonization across different industries and regions. We have done fair amount of work on the steel industry decarbonization in the past 2 decades or so. I started working on steel industry in 2007 when I was in China. And we are very excited to publish a report that I think we can claim is the most comprehensive report of its kind. We have 6 country roadmaps in one report, almost 200 pages, on how to decarbonize the steel industry and moving towards net zero in ASEAN region. With me today, I have also Vijin from Southeast Asia Iron and Steel Institute. Vijin, would you like to briefly introduce yourself while I'm sharing my screen?
Yes. Thank you, Ali. Right. Good afternoon, everyone. I think good morning to some of you who have joined us from Europe and elsewhere. Right. Yes. Way back in 2021, CRC brought back the focus on sustainability for the ASEAN iron and steel industry. I think it was at a time when COVID ended and we were emerging out of it, and we started to see many new developments relating to sustainability. And then we started to observe how things were unfolding over a period of time. And that was a time when CRC, through the leadership of Mr. Somsak Pikaneswan, the chairman of the Environmental and Safety Committee in CRC, we together with the CRC board has decided to embark on this journey to look at the pathways for the ASEAN iron and steel industry. Right. So we started about one and a half years ago, looking at 3 phases of this project. So it's not something that is very fast. So we look at the benchmark policies where we benchmark across a number of countries in Europe, China, and many other places. Phase 2 was on the ASEAN policies. Right? And phase 3 is where we are here today, the final net zero roadmaps for the ASEAN steel industry, where we work with Dr. Ali Hassan Beji and his team at Global Efficiency Intelligence to come up with what we consider to be a timely report on the need for the ASEAN steel industry to decarbonize. So interestingly, I think while working on this report over the last year or so, I think everybody would have noticed a lot of climate changes happening right before our eyes. Flooding, heat waves, storms, and I was in Tokyo last couple of days, and it was snowing in Tokyo, which is highly unusual, So I think we are reminded of the impact of climate change time and time again, Right. So here we are with this report. This report was created with feedback from the national committees of CRC, which includes the representatives of the steel industry in Indonesia, Malaysia, Philippines, Singapore, Thailand, and Vietnam. Right. So all these are the 6 largest economies in ASEAN, all having committed a net zero target to meet their decarbonization goals. Right. So this paper, as we complete it, is meant for the industry to work with the policy makers on how to chart the future for the iron and steel industry in ASEAN. Right. So I would like to thank Mr. Somsak Pikaneswan, the chairman of our Environmental and Safety Committee, plus Environmental and Safety Committee team members, Mr. Ali Hassan Biji, for your thoughts about this area of decarbonization for the steel industry. I think you've done a great job here. And without much ado, I would like to thank all of you for joining us, and I hope that this will become a very interesting and enriching experience to go through what is being proposed. And do participate and share with us your views and ideas where you can. And have a good day. Thank you very much.
Thank you, Eugene, for the introduction. I guess you just jump ahead right into it with the agenda. But before I proceed, just one or two housekeeping items. If you do have questions, please put it in the Q&A box, and we have at the end a Q&A session. And we are recording this and we will make it available as well. The report is published, available on our website as well. So much more detail is there. So yeah, with that, let's get started. I think Eugene very well kind of set the platform and about the background and why we started this and the importance of ASEAN when it comes to steel industry decarbonization. So let's get started with our presentation. We already did the first segment on Eugene's introductory remark, and we are going to have around 35 minutes or so presentation by myself. And my team members are in the US. I happen to be in Asia now, so they won't be able to attend. And then at the end, we will have the Q&A session. So, ASEAN region actually is a very unique region. It's what we call a region at the crossroad. It has significant growth potential, which is happening as we speak, but it does have climate goals. Some of countries quite ambitious, 2050 net zero climate goal. So, a steel industry is one of the heavy industries in this region. A steel demand in the region is quite high. Combined ASEAN region has around 75 million ton per year steel demand. The region ranks fourth after China, India, and the US. And that 75 million ton of steel results into around 77 million ton of CO2 emissions per year, and that was based on our estimate in 2023. And just to put that number in perspective, ASEAN steel industry annual CO2 emissions is higher than the total annual CO2 emission of the country of Austria or Singapore. And actually is higher than total annual CO2 emissions of 160 countries in the world. So a significant number. And unlike China, those of you following steel industry, China has kind of peaked and declining. US has been steady for quite a while. ASEAN is growing and is rapidly growing, and that provides significant challenge. At the same time, countries, most of them, they have 2050 net zero targets, some of them 2060, like Indonesia. But that clashes with this significant expansion we are seeing as we speak in recent years, but also as we speak, it's happening in carbon intensive industries, including the steel industry. So much to be done if these countries are serious about their net zero and they do want to achieve it. Otherwise, it's going to be really difficult with the current trend to get anywhere near net zero. So investment today that are being made, as we observe in the region and the steel industry, is simply locking it in carbon intensive asset and is not in line with the net zero targets that these countries have. So our study, we mentioned ASEAN, but we only focus on 6 major economies, and they are the 6 largest producers when it comes to steel industry. And among them, a couple of them are much larger. Vietnam, Indonesia, and Malaysia, they are the top 3 steel producers, and steel production is mainly relying on carbon-intensive BOF, blast furnace, basic oxygen furnace. And then other countries, Thailand, Philippines, and Singapore, they are 100% electric arc furnace based, although that structure is shifting in some of these countries. And the production that's shown on the left-hand side results in the emissions, annual emissions shown on the right-hand side. And you can see in Vietnam, we are talking about more than 30 million ton of CO2 emissions per year from the steel industry. Indonesia, around 27 million ton. Malaysia, around 14 million tons, and so on. Thailand, Philippines, and Singapore, because of lower production and EAF-based production, their emission is significantly lower. One quick note here, these emissions, they are for steel and crude steel and finished steel production, they do not include some of the standalone rolling mills and that in the regions they present. So if you add them, the emissions for some of these countries will be higher, but we did not include those standalone rolling mills in our study. So as I mentioned, steel production has been increasing. These graphs show the production and demand and apparent consumption and so on for Vietnam on the left-hand side and Indonesia on the right-hand side. Because of the limited time constraints, for some of the things I present today, we will just present examples for one or two or three countries. We cannot talk about all the items for all the 6 countries. Mind you that this is almost 200 pages report I'm trying to present in 30 minutes. So what I present is a very quick high-level snapshot. So as you can see, if you look at the dark blue line, you can see in Vietnam steel production only in the past 10 years increased by a factor of 4 from 5 million ton to over 20 million ton in 2021 and then dropped to around 20 million ton. Indonesia, same story, from around 4 million ton to over 16 million ton. That's only in 10 years increasing by a factor of 4. And it's not stopping there, by the way, especially the new construction. So that is a significant challenge when we talk about decarbonization. So to develop this roadmap, we looked at 5 major decarbonization pillars in the steel industry. And you have seen different versions of this probably from different studies. But basically, we are talking about material efficiency, demand management, circular economy, reducing the demand, and so on. There's a long list of things you can do. We have presented a few examples here. Energy efficiency and electrification of heating. And here by electrification, we mean mainly electrification of like rolling and finishing mills. We do not mean electric arc furnace. That falls into the 4th pillar. The 3rd pillar is fuel switching and cleaner electricity supply, which is very important. 4th is transition to low carbon iron making, like DRI, hydrogen DRI, and low carbon steel making. And last is CCUS. So in our study, we did a detailed assessment on the application and adoption rates of these different pillars for each of the countries under different scenarios, and that resulted into different pathways. So we started our work by doing extensive study of what's the current status and what's the current context of the steel industry in each of the 6 countries. And then from available data and as well as data that the Southeast Asia Iron and Steel Institute provided, we did studies on production and energy use and emissions and so on. So we have the current status, and then we developed 4 different scenarios with different level of ambitions. And for each of those scenarios, we adopted the technologies based on the ambitious level of the scenario. We, of course, increased the ambitious level ambitions of adoption of different technologies and pillars. And we did also do some economic feasibility for some of the key technologies like hydrogen DRI and all. And then we have extensive policy recommendation and action plans recommendations for government, steel producers, steel buyers, etc. So I'll present a snapshot of some of these in my future slides. So this whole process, as Vijin started about a year ago or so, maybe a bit more than a year ago. And throughout this process, we did have multiple touch point and stakeholder engagement. We presented our preliminary results in Indonesia in May 2025, and quite a number of actually steel companies that were in the room and or online. So we got feedback. Then more recently in September, end of September, early October, we had another event in Malaysia for a steel conference where we presented this. On the ground, we talked to different stakeholders, government, steel companies, the Steel Association in Indonesia and Vietnam. We got quite a few round of reviews from CIC, as well as the report was sent to steel associations in different ASEAN countries. So we got feedback from there as well. So it was an iterative process, and a fair amount of feedback was received that was included in the study. The roadmap presents the pathway. sorry, here it mentions Vietnam, Indonesia. It's all 6 countries up to 2060. And we are aware that some of the countries they have net zero target for 2050, but simply given where things are, we think it's unrealistic to assume that they are going to get to net zero steel industry by 2050. So even 2060, I'm going to show you the result. It's quite ambitious. So we wanted to present something that's, while ambitious, is still realistic. That's why we picked 2060 as our target for all the 6 countries. Also, that helps with some harmonization across the 6 countries we studied. The 4 scenarios we developed, there are BAU, moderate, advanced, and net zero. So BAU is always there and net zero is always there. But we also added 2 scenarios, which you might have seen from our previous studies. We usually do to see what the scenarios in between can do and where we can land if we go beyond BAU, but we are not as ambitious as net zero. So let's show you some results. Again, there is a lot in the report. I'll just show you some high-level results. So these are the decarbonization pathway for the 6 ASEAN countries that we have come up with. And these are the results of adoption of various pillars and technologies under them. And that adoption rate under each of the scenario will give us the numbers for the annual emissions that you see on this graph. So the emissions are not assumed. These are the results of the adoption of different technologies under different ambition level that we have for the 4 scenarios. So the graphs here for 6 countries shows annual CO2 emissions between 2023 and 2060 under 4 different scenarios: BAU, moderate, advanced, and net zero. You can clearly see for most countries, with the exception of Singapore, if we go with BAU, we are significantly increasing the annual CO2 emissions. In case of Vietnam and Indonesia, we are doubling it. In terms of Philippines, that could increase by a factor of almost 6 or 7. And these are mainly driven by still the significant growth in the steel production that will be there in these countries in coming decades. However, if we go with the net zero scenario and we pursue aggressive adoption, however, under reasonable pathways, which I will show you more about, of different technologies from energy efficiency all the way to electrification, DRI, and CCS, we can, bend that curve and move towards net zero. But that requires some significant drive from the policymakers as well as the industry. The significant increase in Philippines you see between 2023 and 2030 is driven by the plants that are literally being constructed now and they will come online by 2030. And that's just literally what's happening in short term, but in a longer time frame, that is also happening in other countries. So what is behind these lines and what goes into the assumptions for different pillars? Those are all discussed in detail in the report. But I will talk about a few of those and also open things up a little bit for some of these countries. Let's just start with Vietnam. So the graph on the top right is what I already showed you. Different scenarios, different pathways, and the gap between where you land under BAU in 2060, more than doubling the emissions, and where we need to land in under net zero emissions. So the gap can be filled by different pillars that I showed you and different technologies under them. And we have quantified that. The graph on the lower left side shows the annual CO2 emissions in 2023 and also under BAU in 2060, which will double the emissions. And then to get to net zero in 2060, you can see how different pillars play a role. Like the largest contribution come from technology shift to low carbon steel and iron making and steel making. And that is basically shifting to electric arc furnace, shifting to hydrogen DRI, and etc. But there are other pillars that are quite important. For example, demand management and material efficiency. That's basically Still using steel, developing the country, but better use of steel, managing demand, so we would need less steel. And that's a significant contribution. Energy efficiency and electrification of heating, like rolling, finishing, etc. That has also sizable contributions. As well as fuel switching in certain regions could be kind of switching from coal to natural gas. In many cases, also cleaner electricity as a large portion of that fuel switching and cleaner electricity pillar. You can see CCS plays a role, but the smallest role. The way we modeled CCS in our analysis, we basically adopted all these other different pillars, and then the remainder of the emissions for certain technologies like BF-BOF and natural gas DRI, we put CCS on it to capture that remainder of the emissions. You can see that you can get to net zero without major CCS basically contribution, and that's something that I think interesting finding, because in a BF-BOF heavy regions or countries, people think CCS has to be there and contribute to significant portion. We are saying there are other ways to do it. Also, one thing we modeled was the role of imported green iron. By green iron, we mean green hydrogen DRI produced in other countries where they have cheaper renewable and cheaper hydrogen production possibility. And they produce the green hydrogen DRI or HBI, and then they export it to some of the ASEAN regions. But we were not aggressive about this. Like basically in 2060, we assume anything between 10 to 15% of total steel production, depending on the country, comes from imported green iron. So only 10 to 15%. That means the remainder will be still produced in the country. So if we go with that, you can see we get not to zero, but near zero. The graph on the right-hand side, lower right-hand side, shows you the composition of the technology or the technology mix under the net zero scenario between 2023, what's now, basically. I mean, we are 2026, but our baseline was 2023. And 2060, where we need to go. You can see we basically, in 2030, we are not changing much because trying to be again realistic, not much happening. And given what's happening now, we don't see a major shift by 2030. But after that, by 2040, things need to happen. Again, this is under net zero scenario. You cannot keep building BF-BOF and just hoping to get to net zero or anywhere close to net zero. So you need to start thinking about alternative technologies, low carbon iron and steel making. And you can see even a small adoptions. We are talking about 2% DRI a year and 5% green hydrogen and some natural gas DRI by 2040. And then slowly increasing that even in 2060, like hydrogen DRI, green hydrogen DRI, accounts for only 10% of total steel production. EAF has the largest contribution because all of these countries will have significant increase in domestic scrap supply. And that's what we are seeing in China and any other country. It's just ASEAN is a bit behind. So as the economy matures and grows, that scrap has a cycle. More scrap, domestic scrap, we are not counting on imported scrap, will be available. And that will have significant contribution to decarbonization as well. I think I spent too much time on this. The story in some of the countries have similarities, like Vietnam and Indonesia, more or less the same because the structure of the industry is the same as we speak, and also the trend that we are witnessing. But some other countries, they have different structure, and the story could be different. For example, Thailand. 100% of steel production is scrap EAF based. But we foresee in near future, whether it's 2030 or in the 2030s, there'll be natural gas DRI. Actually, there was a project announced and fair amount of work went into it, but last minute, I believe, got canceled. But there is still a lot of talk having natural gas DRI because Thailand does have natural gas. So you can see the contribution of pillars will be different. If you have mostly scrap EAF and then some DRI, then contribution, for example, you don't need much CCS. If you have DRI, we are assuming that natural gas DRI is slowly but surely will transition to green hydrogen DRI, and that helps with the decarbonization. So in case of Thailand, you can see the contribution of pillars. The largest contribution comes from fuel switching, clean electricity because of big chunk of EAF, and also energy efficiency and electrification of heating. All that rolling and finishing mills use a lot of fuel. They need to be electrified, and so on. And also, imported green iron does play a role. Malaysia has a unique structure at the moment. It does have large BF buff and it has some EAF, but it does have also natural gas DRI. And Malaysia and Thailand are two countries that they do have domestic natural gas resources, which is not the case for many other ASEAN countries. So they can actually utilize that advantage in order to expand their DRI, natural gas DRI, as a transition to green hydrogen DRI as the price of green hydrogen drops in the coming decades. So that's what we are foreseeing. So we are not saying in near term they just go full on green hydrogen DRI. We are aware of the constraints. So as you can see in the lower right-hand side, the technology mix, we are seeing small increase in natural gas DRI by 2030. And then slowly that natural gas DRI kind of switch to hydrogen DRI. And also by 2040, they pilot a CCS under natural gas DRI plan, similar to what's happening in United Arab Emirates. And moving forward, again, there will be significant increase in scrap availability. So that helps with adoption of more EAF and larger share of EAF steel production. And also, we are assuming some imported green iron as well as increased share of hydrogen DRI, which is the natural gas DRI switching to hydrogen DRI, but some of the natural gas DRI will remain, but with CCS. So in 2060, if there is any BF buff or natural gas DRI remains, they need to have CCS with pretty much all of them if we want to get anywhere close to net zero. Very quick on hydrogen DRI. Again, as you saw, we were not like too aggressive on hydrogen DRI. The region has constraints depending on which country you look, and we have discussed that in detail in the report. Some countries like Thailand and Malaysia, they do have an advantage of having some domestic natural gas, so they have more control over the prices, and they can use that transition role of natural gas for natural gas DRI to hydrogen DRI. And some countries, they don't. But regardless, for even the relatively lower contribution of hydrogen DRI, that needs to happen. We need to start having pilots in 2030s and increasing that in 2040s and 50s. We looked into the economics of it. So this is the levelized cost of steelmaking in dollar per ton of crude steel produced for different levelized cost of hydrogen in x-axis shown for Vietnam. Those of you who are following our work, we have published an entire report on the green steel economics. So this is coming from that concept, but we applied it to this study. So what it shows, the black horizontal line is the BF buff steel production cost, which in Vietnam stands a little like north of 450, it's around 470, I believe. And then we also have other horizontal orange lines, which are natural gas DRI. And then the green diagonal lines, they are basically green hydrogen DRI EAF steelmaking. The top line is without any carbon price. The other lines below that is with carbon price. And we assume that, if you produce low carbon steel, you get the carbon credit, you can sell in the market. And that's why you put in your balance sheet. It reduces the cost of the steel production. So there is a lot to unpack here, but basically the moral of the story is the green steel premium. If you produce BF buff, you are basically having a levelized cost of around $460-70 per ton of steel. If you produce green hydrogen DRI EAF in Vietnam with hydrogen price of $5, which is more or less what's the price now, your levelized cost of steel production per ton is basically around more than $800. And that is significant, basically almost doubling, not quite doubling, the cost of production for steel makers. So it's significant. That's why this is not happening. However, if you translate that green premium into unit of final product, then things become more digestible. For example, for passenger cars, we use around 900 kilogram of steel in a passenger car. So if you translate that $800 or so delta from 460 and calculate what would be the additional cost of steel per unit of car, that comes to around $285 per passenger car. Average price of car in Vietnam is almost $30,000. So you can see we are talking about a fraction of a total cost. We also did the analysis for buildings. The green premium per unit of 50 square meter residential building in Vietnam would be less than $800 per the whole unit of building, 50 square meter building. So again, way more digestible. It's like less than 1% of the cost of the car or the unit. So that's why we need to look at new or different way of financing this. And this is how this technology is also happening. The off-takers, the automotive industry is the leader because they know the green premium per unit of car is quite small and more digestible. Okay, to wrap up, I see I'm running out of time. We have around 20 pages of detailed policy recommendation action plans for governments, steel producers, steel buyers, and regional actions that need to be taken, detailed in the report. So here is a 4 or 5 minutes version of it. So the way we looked at it, from what I just explained, you see that the 6 countries could fall into different categories. 3 countries, Vietnam, Indonesia, and Philippines, they are the one that they are heavily reliant on BF buff, and they have constraints with regards to not having, for example, domestic natural gas and so on, and still significant increase in steel production demand, hence the production capacity. Thailand and Malaysia, they do have some advantages with domestic natural gas availability, and Thailand being scrap-based and Malaysia having domestic natural gas production already, they fall. Singapore is a unique case. It just have one scrap-based electric arc furnace plant, not steel. So it's very small. It's just one plant. It's already EAF. We do not foresee any expansion to primary steelmaking in Singapore. So basically, the focus there should be how to move this one EAF plant into net zero. That's its own category. The recommendations based on the context, the constraints, and the advantages of each of these 3 categories of countries are somewhat different as well. For example, the category Vietnam, Indonesia, Philippines, what we say is we need to phase out coal and by phasing out or stopping the heavy coal-intensive BF buff plants. As we speak, there is actually overcapacity in ASEAN. The demand is going to increase for sure because the region is developing. But even the current capacity can provide the increasing demand for the next 5, and many people would tell you 10 years. So there is really no reason for these countries to rush into building carbon-intensive BF buff plants, which will lock them in for many decades. If you build a new BF buff plant, it's almost guaranteed it's going to work for the next 40 plus years because it's going to work for 20 years. They will do at least one time relining, and that expense for another 15, 20 years. So you really lock yourself in, and you definitely miss the net zero target even by 2060. So these countries, the government especially has an important role to stop allowing any new BF buff plants unless really necessary based on detailed study. In our opinion and in our analysis, it's not necessary at the moment. And that will give them time and for hydrogen DRI plants becoming more mature, already DRI plants being built left and right from Europe all the way to China, more and more hydrogen being integrated into them. The price of hydrogen is dropping. So what we are facing now in terms of barrier in 2030 may not be there, or some of them might be lower barriers. So if we can just stop building BFF plant, these countries in 2030 might have much more favorable condition to not lock themselves in BF and just leapfrog to a cleaner production path. Thailand and Malaysia, as I mentioned, they do have the domestic gas advantage. So definitely no BF plant, in our opinion, need to be built there. And natural gas here can play a true transition role. And slowly, again, as the price of hydrogen production drops in the region, they can switch slowly but surely to net zero. Again, we don't want to get to net zero by 2030. We are talking about net zero by 2050, 2060. If Thailand and Malaysia build natural gas plant, DRI plant instead of BF buff, and then just every year they just add 5% and replace 5% of natural gas with green hydrogen, they will get to net zero way before 2060. So there should be a very clear planning there. And for Singapore, it's just one plant. It's all about green electricity supply and electrification of heating for the rolling and finishing part, and also make sure the scrap quality meets the requirement of 2050. Any steel you produce and consume in the society now, quite a bit of it will come for recycling 20, 30 years from now. And that's when you need it, because you're going to have 50% of your steel production in 2050, 2060 from the scrap. So you need to plan for it now. So the scrap then is high quality enough to help you producing high quality scrap steel in 2050. So just to open it up again in some specific recommendations. Again, this is a very short snapshot of 20 pages recommendations. For Vietnam, Indonesia, and Philippines, the most important thing in our opinion is restricting new BF buff approval. It's really not necessary given the overcapacity that they already have and all the pressure they're facing also with aggressive Chinese exports and all that. Prioritize EAF to the extent that you have domestic scrap becoming available. Imported scrap is becoming more challenging because other countries are putting export restrictions like Japan and European. So we are not relying on imported scrap there. And start looking into hydrogen-ready DRI and piloting them perhaps in 2030s. Establishing the performance standards, they need to have mandatory carbon intensity benchmark. You'll be surprised, some of the basics are simply not there as we were investigating these countries' steel industry. So that needs to be there. And honestly, there are great lessons to be learned from just a neighboring country, China. Some of this already has happened there. Green hydrogen hubs can help in the region. Some areas in the regions, they are very favorable for producing low carbon green hydrogen, and the region can benefit from creating these hubs and doing the regional trading of this commodity. And as I mentioned, also scrap, formalizing domestic scrap collection. The infrastructure for scrap collection is still not as good as some of the best practices. So there is a lot to be learned. No need to reinvent the wheel. Other countries are there that are doing better, simply can learn and adopt some of the standards and practices there. Thailand and Malaysia are, I think I already explained this, natural gas plays a transition role. Government seriously need to look into it, but then also need to enable it by infrastructure. Thailand and Malaysia, they're next to each other. They can benefit perhaps from some shared infrastructure and hubs there as well. Significant lack of financial incentive in the region. Like many of these new low carbon technologies adoptions we see, for example, happening in Europe or even in China, they have the backing of the public funds and other funds as well, or some regional funds in case of EU. So we do need financial incentive for some of these new technologies adoption. Southeast Asian countries can do more, but they do need help. That's where the international community and developed countries at G7 can play a role. Something like JET-P, which was for power sector, we needed JET-P for a steel industry, basically. There is a regional play here as well. This is a region that already is thinking, there is already the ASEAN, there is that political platform, is not similar to European Union, but there is an ASEAN entity. And they're already, working on, for example, ASEAN power grid. So there are some experiences there. Of course, it's not moving as fast as it should move. There is trade between the countries when it comes to like power purchase, like Thailand buying, hydropower from Laos, etc. But there is more to be done in terms of interconnected power grid, especially on renewable and clean. But harmonization and carbon rules are very important, especially as this region faces challenges from EU CBAM. Uh, like if this region, which we are proposing, they need to have their own domestic CBAM, because if ASEAN countries have domestic carbon pricing in order to incentivize their domestic steel industry to decarbonize, then they need to protect that by establishing their own CBAM so that dirty steel from China does not just come with the lower price. There is all this harmonization that need to happen. And also a scrap supply. Some countries, they do have fair amount of scrap, but they cannot process it or don't need it at the moment. But some other countries, they have the capacity. So some sort of regional scrap market could really help the region as a whole to decarbonize. To sum up, um, the decarbonization of the steel industry in ASEAN is not a technology problem. Every single technology we need is available now. Like we don't even need to develop any new technology, with the exception of maybe molten oxide electrolysis and all, which accounts for less than 5% of production in 2060, and we don't adopt that technology before 2050. So all the technologies are here. It's a matter of policy, which still needs further development and policy support, and also investment. Governments, countries can do more in terms of supporting the steel industry with the investment, but ASEAN countries, as a developing region, they do need support from international community in terms of financing. With that, I would like to thank you, and I hope you find this helpful. Again, much, much more detailed information available in the report that is published on our website. You can download for free. And lastly, we have published over 30 reports on steel industry decarbonization globally, covering various countries, various topics. If you're interested, check out our website. You might find some of these reports helpful. With that, I would stop and let's have the Q&A session. I think we have around 15 minutes. Vijin, since I've been talking a lot, I wonder if you look at any question that you might be able to answer. Not to put you on the spot. Okay, I think, Vijin, I don't know if you're mute or you drop off. Please do put your questions in the chat box or in the Q&A box, and then we will start answering them. There's a question on our observation about the availability of renewable energy to EAF producers at affordable energy prices within the next 2 years. Well, very good question. And one of the complaints that the steel industry has, and we would agree, is that corporate RE procurement, whether it's power purchase agreement, PPA, or other mechanisms, are not quite developed or enhanced and available in the region, depending on which country. Like Vietnam with the DPPA is doing better, but Thailand, Malaysia, and others, they could do much better. Basically, if you're corporations, you would have hard time if you want to go buy renewable electricity. So that is, in our opinion, the government faults. Just look at what's happening in India. It's one of the best country in Asia and possibly in the world in terms of the direction where things are going with corporate RE procurement. All happened. Government put the proper regulatory infrastructure in place and regulation, and the market picked up, and then significant growth in corporate RE procurement. So yeah, it's a challenge, and the government has a big role to play here, and then let the corporations take it from there. Vijin, is there any question you would like to answer?
Well, I don't have any at the moment, but I think the report is. But I see a lot of questions in the Q&A area, plenty
Yeah.
of them. I think it's good if you could go through them. Yeah.
Yeah. So one question is, how do you project the growth of emissions? Do you use GDP growth? And uh, the growth of emissions are what I showed you, and those are not based on GDP growth. Those are based on which scenarios you're looking at and based on the adoption of various different technologies and pillars and the level of adoption, and that results to certain uh, GHG emission kind of pathways. So I guess the report will answer your question there. So one question is saying, even with all the plausible mitigation measures adopted, the steel industry is not going to be carbon neutral by 2060. What alternatives can this energy intensive industry pursue? If I guess you mean, as we showed in our graph, even in net zero scenario in 2060, you will have some small emissions left. But again, just put things in perspective. In Vietnam, instead of having 66 million ton per year, you're going to have 3 million ton per year or so, if I remember the numbers correct. So that's the win. For that remainder to get it to actually net zero, that's why people call it net zero. I guess you can look into like offsets that are proper offsets and justifiable DAC, direct air capture, or a range of things. So I would say let's not to be worried about that small residual. Let's worry about getting us 95% there. But that's a whole different conversation, I would say. One question on CCS, where the CO2 is going after CCS, domestic or shipped to regional hubs or cluster? Very good question. So again, in the report, you will see we have studied this CCS based on different CCS studies for each country. So some of the countries that have conducted better studies in terms of the carbon sequestration hubs and regions and etc. So some countries, they do have suitable um, uh, carbon sequestration regions. Possibly you can basically put the carbon under the ground, but some not, especially in case of Singapore and others. I need to go. I don't know off the top of my head which one. And for that, perhaps again, the issue with having more like a regional hubs, whether it's for hydrogen, whether it's for carbon sequestration and storage, I think that plays an important role. And that's what's happening also in Europe, like with the Northern Light, they have more of a regional approach with carbon storage. In US, we are having a regional hubs that are being supported for CCUS project as well. So the idea of hub, I think, is not only for hydrogen, also for uh, CCS.
I could probably add a few things to what you mentioned.
Yes,
I
please.
think everyone is aware that ASEAN actually sits on a number of oil basin. It's in the oil basin area, and many countries have a lot of oil, like in particular Malaysia and Indonesia. So there are plans underway to to dig into all these aquifers and see what kind of options we have to store emissions. But I think it is not as simple as we hear it. If you look at the emissions that come out from a blast furnace, for example, there's a complex mix of gases inside there which need further treatment before you inject it anywhere into any of those CCUS systems that are being thought of. I think the governments in ASEAN are very keen to develop this area, especially like Pertamina or Petronas oil areas. They have, I think they are still studying on how they want to do it. It's not going to be so simple as to become a solution for decarbonization immediately, because we still do not know fully how effective this route is for the decarbonization of the steel industry. But it's ongoing. Something will come up, I think, in the near future.
True. Thank you. Um, There is another question on while it is positive to set a net zero target for 2050 or 2060, why can't each ASEAN country commit to a firm, credible decarbonization plan for 2030, one that is granual, time-bound, easy to monitor at the entity level? Um, You mean entity? I don't know. You mentioned country, but then say entity. I assume so. At the country level, ASEAN countries they do have NDC. So the closest you can get to some sort of a target, granular target, NDC. If you look at the NDCs, actually industry is not as granular there in terms of targets and measures. So that's another improvement that in the next iteration of NDC I think will happen, and UNIDO is working on some guidelines to help governments doing that. So yeah, they do have NDC, they do have target, but as all other countries, I guess they're all voluntary whether they hit it or not. Yeah, that's a big question mark.
I could add a
But
bit to
yeah,
what you have said. You
yeah,
know, target setting, I think, is something that everybody does, but whether we can reach it in time or not depends a lot on what unfolds. Whether technology comes up in time, whether CCS is available, whether green hydrogen is going to be cheap enough one day for us to use. But if you were to look at the target of this 2050, 2060, um, basically if you look at the details of some of the NDCs and the announcements made by governments, they have actually highlighted of achieving a carbon peak by 2030, right? Only for Malaysia, it's a bit more 2030, 2035, but by and large, it's all around there, right? I think the governments have been committed. They're going to make their way towards that target. What happens remains to be seen. I think it's something exciting that if you're watching out for.
yeah. Thank you. I'm surprised that you are saying 2030 carbon peaking. We know China has that, but we also know China already built the country, and any projections show that the carbon is going to go down because cement production peaked a number of years ago, steel production peaked. But ASEAN, any projection shows significant increase in some of these heavy commodities, carbon intensive commodity, in addition to car ownership and etc. So in some of the countries like Indonesia, especially, and so yeah, it's yet to be seen. I would say 2030 is just so short term. Don't expect too much from ASEAN as a developing country. When you talk to folks, people here, like uh, nobody is trying to lead in anything. It's just the resources are not there. Yet to be seen some of these technologies to work and implemented in quite a few regions. And then after you provide or certain incentives are provided, I think we will see significant adoption of some of these technologies. That's why in our analysis, we were not so aggressive on near-term adoption on some of these new technologies. Of course, you have to do energy efficiency, demand management, etc. However, there are things ASEAN can do. The most important for some of these countries is what I just mentioned. There is really no reason for building new BF-BOF plant now. They have overcapacity. The current capacity can support the regions as fast as they want to build anything for the next 5 to 10 years. So why would you go build a plant to lock yourself in for like next 40 years? So there are things they can do that has significant implications for the countries. So there's a question on scrap. Yeah, we are showing that large increase in scrap EAF by 2060, and it's saying, scrap quality can vary and what can be done to ensure domestic scrap will be available and good enough. So that's true. Again, if you look at our projections by 2030, we are not really changing anything significant, especially with the scrap. It's more like even 2040, we are conservative, 2050 and 60. And that's simply the scrap cycle. Like just look at any other country. Look at China. Like all the projections in China now show significant amount of scrap becoming available and will be available in the future because all the things they built in the past 20, 30 years, it's just not all the thing, but significant portion comes up for recycling. So it's just looking into the cycle and running the numbers. There will be significant amount of scrap available in some of these countries uh, in 20, 30 years or so. But the way to also plan for that properly, as I mentioned, the steel you're producing now in Vietnam, Indonesia, Malaysia, is gonna mostly consumed domestically, by the way. And then good portion of this skill is still comes up for recycling 30 years from now, 20 years from now. So you better to plan for it now by, for example, reducing, the things that you mix with this, or proper uh, certification, categorization of different scrap, different steel, and so on. So when you have the scrap available, it will be higher quality scrap. So you would need less virgin iron in order to produce high quality steel in 2050, 2060. So things can be done for sure. Any thoughts on that, Vijin, on the scrap in ASEAN?
No, I think scrap is always going to be an issue. Everybody talks about it. I think globally everybody is aware of this problem, but I'm pretty sure that a solution will somewhat come out of it. Whether it's the production of green DR, green HBI, and things like that. So when scrap becomes scarce, of course, prices will go up, right? And when prices are up, then it makes it economically feasible for other alternatives to come in, right? So I think the world has enough iron ore to produce DRI and all that, and with new technologies coming in for green hydrogen, then the possibility of having supply of green HBI will eventually cover what is short coming from scrap.
True. Maybe last question on hydrogen. It's saying our policy recommendations seem ambitious, considering current context and readiness to clean energy transition in the countries, ASEAN countries. Unless large cost competitiveness, green hydrogen supply chain is established, it's difficult pathway. So again, perhaps because of limited time, I could not explain things clearly and really go into detail. In short term, we are basically not adopting any hydrogen DRI in the region. By 2030, I don't think we assume any hydrogen DRI. So the next 5 years. It's just in 2030s, whether it's 2031 or 2039, like 2030s, that result shows in 2040. That's when we are assuming a slow adoption, nothing aggressive, of hydrogen DRI, but mainly actually natural gas DRI as a transition, especially in countries where they do have domestic natural gas. And then some small percentage of hydrogen replacing natural gas. So we are trying our best to be more gradual and as close as possible to the reality on the ground. But at the same time, if you want to get to net zero, you need to do something ambitious. And we do agree the current context and current environment is not as favorable, but things can change. As we have seen, it's changing also in the region. As we have seen, it's changing in, for example, China or India in 2030s and 2035 or so. And then you can see once we have the first pilot, the second pilot, and things can change. But we do need to stop this new BFF plan, because if we keep building them, then in 2030s, you already have too much BFF. That conversation of building hydrogen DRI or natural gas DRI doesn't go anywhere. But I agree, the current context makes it challenging. That's why I said when you talk to folks here, they are not looking into leading. They are like wait and see kind of, and just do the best they can do with the current technology or operations they have. But the biggest challenge is this significant growth in new BFPOF. That's why that was our number one recommendation, which is quite straightforward and simple, but it's quite consequential. Okay, I see there are more questions and there are more in the chat box, which I didn't get to. Sorry about that. I think at the time, but thank you so much for joining. I think we had over 120 people join, which is quite high and shows the level of interest. Please do look at our report. I think that will answer some of your questions. And feel free to reach out if you want to have further conversation. But I would like to thank CIC and also Vijin for supporting this work and not only supporting, collaborating to get this done. I think it will be a helpful resource for different stakeholders in this region as they try to decarbonize this very important sector. With that, thank you so much and have a nice day.
See you. Bye.
Bye, everyone.